Okay. Hi. Hello. I think I'm live. Let's see what are today's problems and stuff. Hi, Coffee. What's up? Um, for now, things look fairly reasonable. Let's see if they stay that way or if we'll have um abrupt ending like we did yesterday. uh, yes. And then I see an error on the YouTube not receiving enough video to maintain smooth streaming. Cool. Hello, King of Agario. Oh wow, Agario. It's been a while since I've done. Isn't it Agar.io or something? I don't know. I've done any of those games. I'm doing well, thank you for asking. Doing great. Just holding my breath. That the stream goes smoothly enough. Inshallah. Let's see. So yesterday we actually got off very abruptly, so yeah, like we left like in the middle of just this. I started running this and I just realized that you have to give it the yes somewhere. So let me give it the yes here so that it goes. By the way, you can actually say custom code equals yes somewhere, so that's also possible. Is YouTube not streaming well? Because like YouTube is telling me that I'm not doing well. Right, we were right here. Let me see. Looks pretty smooth to me. YouTube is being mean. Okay. Yeah, no, looks actually fine. Anyway, yeah, it is okay as well. To my eyes. Alright. We have time, I think. So let's do some learning. Who's with me? So as far as I remember, yesterday we truncated the pre-processing function. Yeah, I remember talking about that. Hello. Hi, yo, what's up? Welcome to today's stream where the unexpected happens. I mean, every stream is where the unexpected happens, but who knows? We need to put ourselves in a try-catch, you know? We don't pay attention to the attention mask of the target as the model won't expect it. Instead, the labels corresponding to a padding token should be set to the -100 so they're ignored in the lost computation. This will be done by our data collator later on, since we are applying dynamic padding. But if you use the padding here, you should adapt the pre-processing function to set all labels that correspond to the padding. Okay. So if you do padding, make sure that the padding is the -100 so that it is ignored by the model. Okay. And then we say map, which means apply our pre-processing to everything. Oh, hi Oliver, what's up? According to my deductioning skills, you probably need to sleep. So do that when it is feasible for you. And then we load our model. Our model has the same checkpoint name as our tokenizer because they're from the same place. Oh yeah, we start with the fine-tuning API. -100 seems large. I think like attention masks for autoaggressive transformers typically. Oh wow. For real? Why is -100 large when they use -infinity? Is that supposed to be a joke? Or do you mean no, even string-wise it's the same length? YouTube is telling me I have 0 concurrent views, and I'm like, okay, but who am I talking to? That's funny. Okay. The actual code using the trainer will be the same as before. Where? When? When is before? For the contribution. Oh, really? Infinity minus infinity after softmax becomes minus 0. Huh. Oh, see that I didn't know. Okay. Cool. Minus 100 would be a zero value. Ah. Cool. I see. Thank you. Thank you for the information. They're not like they even, I don't know, maybe that's what the model expects. Like, could that be the reason, or is there a different reason? Okay, so we have our data pre-processed, the whole data set, and because it's a two split data set. And now we fine-tune the pre-trained model. So here we're fine-tuning using the trainer API. I do want to check if we, like last time we used trainer. Oh my god. We used trainer and then we used accelerator, and now I'm like, let me look at what's happening here. We see the trainer API, and then with Keras. Keras? I don't think I've ever used that. And then a custom training loop. That's really cool. Okay. We'll be scared when we get there. Should I zoom in a bit more? Or does my head cut it off? It does though. Zoom out. Okay, that seems somewhat better. The actual code using the trainer will be the same as before, with just one little change. We will use a sequence to sequence trainer here, which is a subclass of trainer. Okay. That will allow us to properly deal with the evaluation using the generate method to predict outputs from inputs. We'll dive into that in more detail. Okay, so we're talking about logits, right? Or is that first things first? We need an actual model to fine tune. We can't just we'll use the usual auto model API. Okay, meaning we just load the model. We're calling it sequence to sequence language model, LM, from pre-trained, and that's our model. Okay, so we load our model. Code is like too zoomed in though. It's better. And then we do the collation. Note that this time we're using a model that was trained on a translation task, obviously, and can actually be already used. Yeah, it's a model, like it's ready to be used. So there's no warning about missing weights. So for the collation, because we need the dynamic padding for the batches, we can just use, why not, data collator with padding like in chapter 3 in this case, because that only pads the inputs. We have two things to deal with. We have the input and like the source and the target, right? Input and target, I think that's what they're called. Like the language you want to translate from and the language you want to translate to. Okay. So input IDs, mask attention, and token type IDs. Our label should also be padded with the maximum length encountered in the labels. And as mentioned previously, the padding value used to pad the label should be minus 100 and not the padding token of the tokenizer to make sure those padded values are ignored in the loss. Okay, so they will be ignored for computing loss. This is all done by data collators for sequence to sequence, like the data collator with padding. It takes the tokenizer used to pre-press the input, but it also takes the model. We call it, we give it the tokenizer, we give it the model. Cool. This is because the data collator will also be responsible for preparing the decoder input IDs, which are shifted versions of the labels with a special token at the beginning. Since this shift is done slightly differently for different architecture, it needs to know the model object. So we give it the model so that it knows the architecture. Okay. To test this on a few samples, we call it on a list of examples from our tokenized training set. So we load it, and then we say, give us 3 examples, shows the keys. We have input ID, attention mask labels, and decoder input IDs. And then if we look at the labels, like what's inside, right? Labels. This is what we see. This is 2 different things, right? Oh no, this is padded. This is way padded. No. Okay. Decoder input ID. This is the code for the padded thing. I need to read it. What's happening? So we're just looking at what's in there. We can check our labels have been padded to maximum length using minus 100. I saw that, yes. And then we can have a look at the decoder input IDs to see that they're shifted versions of the labels. Is it? So 577, 5891, and then we see that they're shifted by 1. Everything is shifted by 1. Cool. Yeah, even if I run it, I'll see the same. I don't see the same. Oh, sorry. Here. This is what does the shifting. Cool. And what are you? Labels for the first and second element in our data set. Cool. So we give them, and now metric. Let's see what metric we're using. What is the blue metric? Not blue, blue. Let's see.
What is the blue metric? For many NLP tasks, we can use common metrics.
Darn it, they're not French. He didn't say bleu, he said blue. Anyway.
What is the blue metric? For many NLP tasks, we can use common metrics like accuracy or F1 score. But what do you do when you want to measure the quality of a text that's being translated from a model? In this video, we'll take a look at a widely used metric for machine translation called BLEU. The basic idea behind BLEU is to assign a single numerical score to a translation that tells us how good it is compared to one or more reference translations. In this example, we have a word in Spanish that has been
one or more reference, that makes sense.
Translated into English by some model. If we compare the generated translation to some reference human translations, we can see that the model is actually pretty good, but has made a common error. The Spanish word tengo means have in English, and this one-to-one translation is not quite natural. So how can we measure the quality of a generated translation in some automatic way? The approach that BLEU takes is to compare the n-grams of the generated translation to the n-grams of the references. Now, an n-gram is just a fancy way of saying a chunk of n words. So let's start with unigrams, which corresponds to the individual words in a sentence. In this example, you can see that 4 of the words in the generated translation are also found in one of the reference translations. And once we've found our matches, one way to assign a score to the translation is to compute the precision of the unigrams. This means we just count the number of matching words in the generated and reference translations and normalize the count by dividing by the number of words in the generation. In this example, we found 4 matching words and our generation has 5 words. Now, in general, precision ranges from 0 to 1, and higher precision scores mean a better translation. But this isn't really the whole story, because one problem with unigram precision is that translation
it doesn't account for repeated things.
Models sometimes get stuck in repetitive patterns and just repeat the same word several times. If we just count the number of word matches, we can get really high precision scores, even though the translation is terrible from a human perspective. For example, if a model just generates the word 6, we get a perfect unigram precision score. So to handle this, Blue uses a modified precision that clips the number of times to count a word, based on the maximum number of times it appears in the reference translation. In this example, the word 6 only appears once in the reference, so we clip the numerator to 1, and the modified unigram precision now gives a much lower score, as expected. Another problem with unigram precision is that it doesn't really take into account the order in which the words appear in the translations. For example, suppose we had Yoda translate a Spanish sentence, then we might get something completely backwards, like years 60.
That's a good example. It doesn't care about... Wait, Blue doesn't care about order? Alright.
30 have I. In this case, the modified unigram precision gives a high precision, which is not really what we want. So to deal with word ordering problems, Blue actually computes the precision for several different n-grams and then averages the result. For example, if we compare 4 grams, we can see that there are no matching chunks of 4 words.
It does. Okay. Yeah. N-grams are the answer here.
In the translations, and so the 4-gram precision is 0. Now, to compute Blue scores in the datasets library is really very simple. You just use the load metric function, provide your model's predictions with their references, and you're good to go. The output will contain several fields of interest. The precisions field contains all the individual precision scores for each n-gram. The Blue score itself is then calculated by taking the geometric mean of the precision scores. And by default, the mean of all 4 n-gram precisions is reported, a metric that is sometimes called Blue 4. In this example, we can see that the Blue score is 0 because the 4-gram precision was 0. Now, the Blue metric has some nice properties, but it is far from a perfect metric. The good properties are that it's easy to compute and it's widely used in research, so you can compare your model against others on common benchmarks. On the other hand, there are several big problems with Blue, including the fact it doesn't incorporate semantics and it struggles a lot on non-English languages. Another problem with Blue is that
really? It doesn't accept Unicode?
It assumes that the human translations have already been tokenized, and this makes it hard to compare models that use different tokenizers. So as we've seen, measuring the quality of text is still a difficult and open problem in NLP research. For machine translation, the current recommendation is to use the Sacra Blue metric, which addresses the tokenization limitations of Blue. As you can see in this example, computing the Sacra Blue score is almost identical to the Blue one.
You can't help but call it Sacra Blue, and not calling it, Did it sound French? It's funny though.
The main difference is that we now pass a list of texts instead of a list of words to the translations, and Sacra Blue takes care of the tokenization under the hood.
Wait a second.
Precision scores.
So you give it separated, tokenized in a way, like segmented word, but here you actually give it the whole thing together. Cool. And then references. I don't think you have multiple references. I may need to do a BRB. So BRB. Maybe not right now. I guess not. Okay. Cool. And now we sort of know what's Blue or Sacra Blue. Oh wow, that's really zoomed in. So the feature that sequence-to-sequence trainer adds to its superclass trainer is the ability to use generate method during evaluation or prediction. During training, the model will use the decoder input IDs with an attention mask. Using it does not use the tokens after the token is trying to predict. Ensuring, how did I read this? Okay, so because of the attention mask, it will not like look to the future, I'm guessing. It does not, to speed up training so that our training is faster. Got it. During inference, we won't be able to use those since we won't have labels, so it's a good idea to evaluate our model using the same setup. Okay. As we saw in chapter 1, you expect me to remember things from chapter 1? Wow. The decoder performs inference by predicting tokens one by one, something that's implemented behind the scenes in transformers, HuggingFace transformers, generate method. The sequence-to-sequence trainer will let us use that method for evaluation if we set predict with generate equals true. The traditional metric used for translation is the BLE score, introduced, oh my god, 2002. Wow. By Kishore. The BLE score evaluates how close the translations are to their labels. I don't know if you guys can hear this sound coming outside when I'm talking, but if you do, try to guess what it is. It's a piercing sound. Don't know if you can hear it. How close translations are to their labels. Okay. It does not measure the intelligibility or grammatical correctness of the model's generated outputs, but uses statistical rules to ensure that all the words are in the generated output also appear in the target. In addition, there are rules that penalize repetitions of the same words if they're not also represented in the target to avoid outputting repeated sentences. And the output sentences that are shorter than those in the target to avoid the model. Okay. One weakness with the BLE is that it expects the text to already be tokenized. Right. Which makes it difficult to compare scores between models that use different tokenizers. So instead, most commonly used metric for benchmarking translation models today is the Sacre Bleu, which addresses this weakness and others by standardizing the tokenization step. Cool. To use this metric, we first need to install the library. What does it mean? I don't think I know what it means. Oh, it's a surprise, irritation. A negative surprise. That's so cool though. Oh my god, we have that. Yeah, calling the lords. Got it. I need to know the pronunciation. Why are these more than a minute long? I'm guessing it's a...
Sacre bleu.
Yeah, Sacre Bleu, expected. Cool. My... Okay. Now we install the Sacre Bleu. It's like, oh my gosh. With a Wait, is it replacing the term God with a different word? Huh. Loading. So it's not actually calling Lord's name in vain. I see. Is it? That's interesting. Okay, sorry for being quiet. This metric will take text as input and targets. Metric takes text as input and target. It is designed to accept several acceptable targets, which is great, as there are often multiple acceptable translations of the same sentence. Oh yeah. Original is you. So blue actually just means blue? Like, oh my blue? The data set we're using only provides one. Yes, I'm aware of that. Now I don't think, that's interesting. It's not uncommon in NLP to find data sets that give several sentences as labels. Scared? That's cool. It's funny, sorta. Okay. You guys can't hear the background sound, right? Like, there's a kitten screaming its head off. I don't know where's her mom. I mean, I know she's around, but anyway, she's just meowing too much. Prediction should be list of sentences, but references should be a list of lists. References can be more than one. Got it. So predictions, references. And then this is like just one example that we have written by hand, giving it to Blue, Sacre Blue actually. Standardization, that makes sense. I know, Ned Flanders, yeah. No meows, got it. Ned Flanders is cute. So this plugin lets you translate web pages between several languages automatically, and then it says automatically translate. Wow, this is like a 1-for-1. This is like 100% though. Wait, I don't know. Precision 91. I don't know what the score is supposed to mean. Because of the things not being, anagrams not matching, that might lower the score. You might have it wrong. It's cool. It can be Ned Flanderization. Or, I don't think we do that though, like here. Maybe for swear words, but not for like saying, oh my god. I don't think we do that. This gets a blue score of 46, which is rather good for reference. And the transformer model in the attention is all you need paper, which was translator model, got a 41 on translation between English and French. But I don't know what is that supposed to mean. Individual metrics like counts and BP. No thanks, I'm good. On the other hand, if we try with two bad types of predictions, bad, okay, lot of repetition or too short, that often comes out of the translation models, we get bad blue scores. But like, what is the highest score you could get? Is it 100? If so, 46 is not that great. I mean, yeah, this, you get a 1. Precision is 25, which, okay. And then here, oh wow, score of 0. Why? Because of engrams? What about this one? That's odd. The score can go from 0 to 100. The higher is better? Well, that's not, I mean, it checks for like, similarity. To get from the model output to text, the metric can use, we will, let's do it on our model. Got it. We'll use the batch decode method. We just have to clean the -100s up in the labels. Tokenizer will automatically do the same for the padding tokens. Cool. So we take the logits, prediction labels. If it's a tuple, we take the 0th, and then we say batch decode, and then we say where -100, give it everything that's not -100, and then you again decode, twice. One for prediction, one for labels. And then you say, this is like, strip is like trim, right? In Excel sheets. And then you say, these are my decoded predictions. These are my decoded labels. Sacrebleu, tell me what this is. No, is it? Wait, no. Metric, yes. Our metric is Sacrebleu. And then this is bleu. This is the score. Now this is done. Oh, we just prepared the metric. This was a function that prepares the metric. 그래. Okay. I am not gonna ask for more. I'm gonna pause here. Even though I know, sometimes watch an atheist religious scholar and he pronounced YHWH as what? I don't understand. Don't I? How? Why? Oh God, my information is very limited. That's cool though. Being respectful to other people. There are a lot of ways people modify language not to offend. But like, I guess my pronunciations that are related to Jewish things are mostly coming from an Arabic source, so I can't know why this is not. Oh God, sorry, I punched the mic. I don't know why it would be, but yeah, I'm just saying my pronunciation is probably different. Is this supposed to mean Yahya? Because I don't think that is that. That's cool. Being respectful is nice. I'm not gonna do. I spoiled the metric. I'm not gonna continue here. Fine tuning the model. Was I? Did I? Am I? Wait. Data collection. Oh, trainer API. Where is that? That's not here. We're here. We looked at data collection, we looked at metric, and now we're here. The Torah didn't have vowels. Oh, YHWH. It's like a translation for the written name of. Oh. But one shouldn't say it in some faiths. And The exact vowel sounds are known. I didn't know that. Oh, I've heard that. I've heard that being said. Oh, I've heard that being said many times. Okay, got it. Ah, yeah, I've heard that actually. Cool. But I didn't know the thing behind it. That's really cool. That's really cool. Oh, why is my computer not being charged? Cool. Now it is. So I'm gonna pause here, but I'm not gonna go yet. You are not gonna get rid of me so easily. Should we come here? Because I don't know. What did we do this last, or did we do linguistics last? I'm guessing we did linguistics last, so I think we are do this, right? I don't remember. Okay. So retriever, reader models.
Okay, so now moving on to actual retrieval augmented generation models. We have retriever reader models. And the way these work is you basically, the simplest way they can work is you basically just chain retrieval and reading together. So you use an out-of-the-box retriever and an out-of-the-box reader model, and you have your query. You could, for example, look something up on Google, get a whole bunch of passages, and then feed them into a GPT model.
Cool. Like on the back end, or like as a just prompt.
And get an answer. This overall is quite effective. It's easy to implement and it will give you decent results. So definitely it's something to be worth thinking about. For assignment 2 um, in the class, you're required to only use kind of public models or open source implementations. So you could.
Can you tell I'm trying to not do another assignment because first one didn't go as well. I didn't even read what is the second. I think it's like create a rocket to go to the moon or something. Like it's too much. Too much. Let's look at assignment number 2. End-to-end NLP system building retrieval. Oh, it's RAG. It's a group assignment, people. We can cheat with this one. There are 3 assignments, though. Due date is almost 1 month after the first one. And then the other one is like, you have 2 weeks. Wait, no, is it? So we're using RAG. We're just like fine tuning using RAG, which is not called fine tuning, right? God, I'm scared. Ah. Oh, okay. You can even use Olama. That's actually pretty cool. Because like you literally need nothing to run it. Yeah. Yeah. I know. They expect so much from their students. Wow. I'm both jealous and relieved that I'm not their official student. Has anyone seen Inside Out 2? Because there's a, what is jealousy? Is it just jealousy? Is there a different word for it? Greed, maybe? Character in there. And I felt it.
Still replace that with Apache Lucene.
Less about looks and more about skills, you know?
And then, any standard LLM. And that could be, Llama Chat or Mistral or Mixtral or something like that. So you could definitely feel.
I wonder if students do well, they're singled out for like honest. Honors. Oh. I thought you were like, are they honest about their um hmm. I'm guessing like one thing that they would be singled out for is like being assistant. What are they? It's not assistant lecturer, is it? You're just like teacher's assistant. There we go. TAs. That's it. I'm guessing that like they might even be asked to join research groups. That would be cool, right?
Feel free to do something like that. Of course, the passages are concatenated to the context. And so because the passages are concatenated to the context can get relatively long and expensive and other things like that, but it's just something you have to deal with when you're using RAG. There are methods also for retriever and generator end-to-end training. So this is the paper actually where the name RAG came from, and I'll use that as an example here. But basically, there are several methods that propose to train the retriever and reader to improve accuracy.
Here's more postgrad. I mean, yeah. I don't know. I think I've heard that like 4th year or 3rd year students TAing 1st year classes. I don't know, but you know, like I've watched videos of people saying this is how my bachelor's went or this is how my master's went. So but yeah, I think they have been more like masters or PhD students. I don't know. Honors is definitely different. Oh no, I don't think PhD is TA level though. Like now that I think of it, I don't think for PhD it's a TA. Candidates, maybe. But I think they would be like actually like assistant lecturer or something. Like they should have teaching experiences, and they teach a class. That's what I've heard in like contexts that are relevant to me. You're not obviously an actual lecturer, but you can teach a class, or maybe help a teacher teach a class. Which does that make you a TA when you do the practical sessions? And the teacher does the theoretical session? I don't think that's a TA. I think a TA is basically like a glorified intern. Like I don't know. Can't be sure. But I as far as I know, there is pay for TAs as well, no matter how little. Could be wrong though. Like, oh hi Michael. Michael is now talking, no longer silent. What's up? Is Inside Out good? I've been reluctant to watch it. Have you seen the first movie? I mean, as a person who lives on the internet, like my movie watching experience has changed so much. Like I was so bright-eyed and innocent when I was watching movies as a kid. Like everything was good, and now I'm like, I don't like the way they hold the camera or something. I've gotten too, I don't know. I know too much. You know, like you have movie sins in your brain, and then you have Ryan George in your brain. All of that. So is it good? I do believe that it's good. I think there's a level of like Turning Red. It was very much about young girl's experience. So I think Inside Out has that style to it. It's about like first movie is about a girl in like primary school, and then second is like middle school to high school. So it's still like very enjoyable, and it's still about human emotions. But like watching it with a family member would be fun because it has themes of family as well. I don't think movies have gotten worse, I swear. Like when I see people watching movies that I watched as a kid and give it the same critique, I'm like, oh, but I really like that. Like I lived off of that as a kid. Like I would watch it and watch it and watch it. And now you're critiquing it the same way you're critiquing new movies. Okay, I see where this is coming from. The only thing that I understand, that like something's gotten worse. Oh, hi, someone's on. I'm gonna wave to them on Discord. Anyway, the only thing that I think is changed is I saw a post on Reddit yesterday saying that subtitles are needed because sound mixing is different now. I think that's the only thing that's changed. I've always used subtitles, so I'm good. English needs subtitles, Korean needs subtitles, Arabic needs subtitles, everything needs subtitles. I think the only thing I don't use subtitles is like my native language. And I don't think there are subtitles. I've never looked. I'm kidding. Okay. Saw a Reddit post of someone shocked that their kids had laughed at like one of the traumatizing scenes from Who Framed Roger Rabbit. Like maybe one of the characters becoming ooze, like dying. I think we are somewhat desensitized. Desensitized, yeah, that's the word. To violence a bit more, just a bit more. Video games, what they've done to the kids. I'm kidding. But yeah, still, it does actually, like, seeing things makes it normal. That isn't interesting. I do recommend you watch Inside Out, though. I don't know if that sounded like a recommendation or like, I'm just saying, like, it may be more relevant. Actually, you know what? Making friends is always relevant to everybody. Yeah. It is about, it's about loneliness, making friends, stuff like that. And like doing too much. Like that's the second movie where she's like, I need to be the best. Can't relate though, right?
There are several methods that propose to train the retriever and reader to improve accuracy. And specifically, the RAG paper by Lewis et al., the way it trained the reader was to maximize generation likelihood given a single retrieved document. And for the retriever, it maximized overall likelihood by optimizing the mixture weight over documents. So here's kind of a schematic, which is...
What's happening here? I see query encoder, I see document, I see generator. Is this like the RAG thing inside?
Is you have your query encoder, you run the retriever with maximum inner product search.
What age were you when you realized you can move the CC of YouTube around? Like I figured out sometime in the past, but I don't know. I don't think it was early enough.
It gives you several documents, and each document has a score. And then based on the documents and the scores, you generate with each document in the context, and then sum together the probabilities multiplied by the weights. And I have the actual equations here because I think it'll be a little bit easier to understand after looking at the equations.
Really?
So generation is a mixture model, and you pick a document and generate from the document. This P eta Z given X is the probability of picking that document given the query X.
Probability of picking a document given a query X. Okay.
And then this P theta, X, Z, and all of the previous tokens is basically the probability of the next token given that you have this particular document.
Probability of next token given a particular document. I think it was after I realized it. Oh, VLC does the same? Not sure when YouTube got the feature. If it had it when it used Flash Player. Yeah. VLC. I like VLC. Yeah. Has a lot of like good settings that you can like go in there and just mess with everything.
So you can see that this is basically linearly interpolating between the multiple documents. And if we look, this can be considered the retriever and the generator, the retriever and the reader. One really important thing here that enables end-to-end training is they have this probability of the retriever be based on embeddings. And so here we have the document embedding and the query embedding. And the probability is proportional to the inner product of these exponentiated. So you're basically taking a softmax over the inner product between the two.
Okay.
And this adjusts the retriever to give higher similarities to helpful documents. And so because the probability of the retriever model here is included in the end-to-end probability, you don't actually need any annotations about which documents are useful. You can just train all of this end-to-end and let backprop do its thing to update the retriever as well.
Okay.
One important issue when training models like this is that the search index will become stale. So what do I mean by this? If we go back to our previous thing about dense models, creating this blue search index on the right side of the figure here is very costly. So like, let's say you want to embed 1 million documents or 1 billion documents if you're a big search engine company. So doing this is very slow. And in contrast, doing lookup with kind of these approximate nearest neighbor searches is sublinear time or even, log time. So you can do it relatively quickly. So it's fine to do lookup over this big index, but if you start updating this document embedding, you need to recreate the entire index, and that would be, very
Wait, you can't append to it?
Computationally costly. So the solution to this proposed in this RAG paper by Lewis et al. Is we only train the query embeddings and we keep the document embeddings fixed. There's other alternatives like there was a paper called Realm from early in retrieval-based modeling. And in that method, they basically had an asynchronous process that was going through and using the most recent document embedder to re-update the search index during training. But that is, kind of a very onerous process. So I think it's quite common to use kind of a fixed document embedding and update only the queries.
Cool.
Another thing to think about.
Yeah, no, that's it. I am out of time and I need to run away. To there. Time locked. Got it. Thank you for yay, hi. So yeah, we did the translation, data collection, and the metric. Yes, because we did the data processing yesterday. And today we also looked at some RAG related things. I hope you had fun. If you'd like to, remain updated, you can do that, whether it's on YouTube or Twitter, on Discord. Good luck. Have a great day as well to you. Yeah. I need to go. It's a Wednesday. Week half done. We did it. Yeah. See you. Oh, I was thinking actually taking weekends off. I don't know how that will work because I think I want to make content and like this is the only time that I can do stuff that is outside of stuff. So maybe I'll get back to you on that. That's it. Have a lovely rest of the the day, or if it's night, have a lovely night. I will do a countdown of 5 and end the stream. Oh wow, my hand is cut off. And then that's it. Yes. Thank you so much for being here and for chatting with me. Ending the stream in 5, 4, 3, 2, and 1. Thanks. Goodbye.